The total memory capacity of a computer can be visualized by hierarchy of components. The memory hierarchy system consists of all storage devices. The storage devices contained in a computer system from the slow auxiliary memory to fast main memory and to smaller cache memory. Auxiliary memory access time is generally 1000 times that of main memory. Hence, it is the bottom of the hierarchy. When the program not residing in main memory is needed by the CPU, they are brought in form of auxiliary memory or not needed by main memory are transferred into auxiliary memory to provide space. The main memory occupies the central position because it is equipped by committee of directly with CPU auxiliary memory devices through input-output processor. The cache memory is used to store program data, which is currently being executed by CPU. Approximate access time ratio between cache memory and main memory is 1 to 7 to 10. And this is the flowchart representation. The magnetic tapes and magnetic disk comes under auxiliary memory. Whereas the main memory and cache memory comes under primary memory. So these are the different hierarchies of the memory. Main memory is called primary memory, and magnetic disk and magnetic tapes comes under auxiliary memory. Here we call the level 0 and here level 1. It is the increasing order of access ratio. It stores the data and program during computer operations, and it uses the semiconductor technology. Semiconductor memory is of two types: volatile and non-volatile. Volatile memory consists of RAM, random access memory, and non-volatile consists of ROM and flash, where RAM memory will be erased whenever the system is erased, whereas non-volatile will be stored permanently in ROM and flash. Non-volatile memory retains the data even when turned off. Example, flash memory and ROM memory. Again, ROM has different types: ROM and EROM, whereas ROM means programmable ROM EEPROM means erasable prom, whereas EEPROM means electrically erasable prom are commonly used proms. There are three types of memory access methods. First one is random access, and the second one is sequential access, and the third one is direct access. Whereas main memories are random access memories, in which each memory location has unique address. Using this unique address, any memory location can reach same amount in order. Sequential access. This method allows the memory in sequence, whereas direct memory access, in this mode, information is stored in tracks, with each track having separate read and write head. Okay. RAM memory has different types: DRAM, SRAM, and NVRAM. Dynamic RAM is made of capacitors and transistors, whereas static RAM has a 6 transistor circuit in each cell and retains data until Power off. Non non-volatile RAM retains its data even when turned off. The data or contents of the main memory that are used again and again by CPU are stored in the cache memory so that they can easily access the data in shorter time. Whenever the CPU needs to access memory, it first checks the cache memory. If the data is not found, the cache memory in the CPU moves into the main memory. It also transfers block of recent data into the cache and keeps on deleting the old data in cache to accommodate the new one. Associative memory. It is also known as content addressable memory (CAM). It is memory chip in which each bit position can be compared. In this content, each bit cell will allow very fast table lookup. The address value of 15 bits is 5 digit and 12 bits is 4 digit octal number. Since an entire chip can be compared to contents randomly stored without considering addressing scheme, these chips have less storage capacity than memory chips.